we are going to review for your conceptual unit 2B exam. Add or subtract and simplify. So we have 3 plus 9i, because nothing's touching the walls there. Distribute a positive, which changes nothing, which gives me, excuse me, my nose, positive 5 minus I. And then you combine like terms. Real to real, imaginary to imaginary. So 3 plus 5 is 8. Positive 9i minus 1i would be positive 8i. Done. Okay, multiplying them, you distribute just like you would if they didn't have i's in them. And for the most part, i's act just like x's or y's or any other variable, except for when you get 1 squared, then it turns into a real negative 1. So I have 7 times 8 is 56. 7 times negative 5i is negative 35i. Positive 2i times 8 is positive 16i. Positive 2i times negative 5i is negative 10i squared. We're going to combine like terms and replace I squared. That's going to give me 56. I have negative 35 plus 16 is negative 19i minus 10 times negative 1. So if I simplify that, I'm going to have 56 minus 19i plus 10. Combine like terms one last time, and I have 66 minus 19i. Okay? Expressed in terms of I. Anytime you have a negative, this is like the square root of negative 1 times the square root of 36. Well, the square root of negative 1 is I, and the square root of 36 is 6. So my answer would be 6i. Okay, find the real numbers x and y that make the equation true. I have 3 plus 5i on the left. And on the right, I have x plus yi. Well, these are both complex numbers, and the author is claiming that they are equivalent. Well, the only way that can happen is if the real on this side is equivalent to the real on this side. They look different, but they have to be equal. And the I term has to be equal to the I term on this side. So 3 has to be equal to x, and 5i has to be equal to yi. Get x and y alone. This one's a pretty simple case. That one is alone. Divide by I, and y equals 5. Okay? Alright, so multiply. If you want to do this without killing puppies, you have to make 2 copies. And FOIL. 4 times 4 is 16. 4 times 6i is 24i. Positive 6i times 4 is positive 24i. Positive 6i times positive 6i is positive 36i squared. Combine terms in the middle, replace I squared. I'm going to have 16 plus 48i plus 36 times negative 1. Distribute, I'm going to have 16 plus 48i minus 36. And I'm going to have, real first, so I'm going to have negative 20 plus 48i. And that's as far as I go. Okay, find the product of the complex number and its conjugate. The complex number is negative 5 plus 3i. If the conjugate, hold on just a second, I don't know where that noise came from. Let me just make sure that, okay, never mind, we're still going. Alright, the conjugate of negative 5 plus 3i would be negative 5 minus 3i. And to take the product means to multiply. So distribute negative 5 times negative 5 is positive 25. Negative 5 times negative 3i is positive 15i. Positive 3i times negative 5 is negative 15i. Positive 3i times negative 3i is negative 9i squared. Combine terms in the middle. Replace I squared on the end. I have 25. The i's cancel. Minus 9 times negative 1. Okay, distribute. I have 25 plus 9, which gives me 34. Okay, notice that when you multiply conjugates together, the imaginaries all die, and the last one is squared, so it turns into a real negative 1. Okay, it says write the quotient in the form a plus bi, where a and b are real numbers. They're telling you to divide, but they can't really say divide because you can't divide by I. Okay, so what you do is you rationalize the denominator, which means we're going to multiply the top and the bottom by the conjugate of the bottom, which would be 5 minus 6i. I don't care what's on top, whether there's an I on there or not, it does not matter. To rationalize a denominator, you multiply the top and the bottom by the conjugate of the bottom. So on top, when I distribute the 1, 1 times 5 is 5, 1 times negative 6i is negative 6i. On bottom, when I FOIL these out, I'm going to have 5 times 5 is 25, 5 times negative 6i is negative 30i, positive 6i times 5 is positive 30i, positive 6i times negative 6i is negative 36i squared. Combine like terms in the middle, which those will cancel. They always will on conjugates. Replace the I squared. So I'm going to have 25 minus 36 times negative 1, which is 25 plus 36, excuse me, which is 61. So my bottom would be 61. And that would be my answer. Now remember, Math Excel likes it to be split up, and all they're doing is they're saying both of these get divided by 61. So they said it's 5 over 61 minus 6 over 61, and they put their I on the outside. This is perfectly acceptable, again, except if you're working on Math Excel. Alright, solve for x. Well, this is a second degree, a quadratic. My first instinct is to try and factor. Well, if I do a times c, or just factors of c, factors of 18, 1 and 18 can't make 6. 2 and 9, no, I could make 7 or 11. 3 and 6 could make 3 or 9. 4, no. 5, no. 6 and 3, I'm out of factors. If you can't make b, you can't factor it. So we're going to use our handy-dandy quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so in my case, a is 1, b is negative 6, and c is 18. So x equals a negative 6 plus or minus the square root of negative 6 squared minus 4 times a times c all over 2 times a. Okay, then I like to simplify underneath the radical first. So negative 6 squared minus 4 times 1 times 18 is negative 36. So I have x equals positive 6 plus or minus the square root of negative 36 all over 2. Now, on that negative is going to come out as an I, so I have 6 plus or minus, the negative comes out as I, and the square root of 36 is 6 all over 2. Then I can reduce all of those by 2, and I get x equals 6 divided by 2 is 3, plus or minus 6 divided by 2 is 3i, over 2 divided by 2 is 1. So x equals 3 plus 3i, and x equals 3 minus 3i. Okay? Which I had to get two solutions. I did. They're both imaginary, which means this won't touch the x-axis. Okay, this one says write the polynomial in standard form and identify the zeros of the function and the x-intercepts of its graph. Okay, I'm going to do this a little backward. I'm going to start finding the zeros first, because that makes the most sense when you're looking at factors. So I have this function, x minus 12i times x plus 12i. If I want to get the zeros from that, you set the factors to 0 and solve. We'll get x alone. So add 12i, x equals 12i, minus 12i, so x equals negative 12i. Okay, so those would be my zeros. Then it wants the x-intercepts. Well, guys, if they have i's in them, they're not going to cross the x-intercept. I mean the x-axis, because they're both imaginary. That means they're not real. So as far as my x-intercepts go, there aren't going to be any, because both of my zeros have i's in them. Okay, and now to write it in standard form, which is back at the beginning, you multiply your factors together. Okay, so you take the same function, x minus 12i times, these are conjugates, by the way. Okay, you're not solving it right now, you're just rewriting it in a different language pretty much. And we do that by foiling this out. X times x is x squared. X times positive 12i is positive 12xi. Negative 12i times x is negative 12xi. Negative 12i times positive 12i is negative 144i squared. Combine like terms in the middle, which those cancel because of the conjugates. Replace I squared. I get f of x equals x squared minus 144 times negative 1. And my final function is f of x equals x squared plus 144. And there's my function in standard form. Okay. Alright, this one says write a polynomial function in standard form with real coefficients whose zeros include 4, 10i, and negative 10i. Same instructions, they're just, instead of them writing f of x equals factor times factor times factor, they're telling you what the zeros are. Okay, so they're telling you that x equals 4, that x equals 10i, that x equals negative 10i. So its factors, minus 4, I get x minus 4 equals 0, minus 10i, x minus 10i equals 0, add 10i, x plus 10i equals 0. These are my factors for my function. My function will be in factored form, x minus 4 times x minus 10i times x plus 10i. Now, you can multiply in any order you want to. If I have conjugates, I always multiply my conjugates together first because they eliminate i's and it becomes much simpler. So I'm going to drop this one for now and I'll multiply by it later. Okay, so this I'm just dropping. X times x is x squared. X times positive 10i is 10xi. Negative 10i times x is negative 10xi. And negative 10i times positive 10i is negative 100i squared. So if I clean this up, the middles cancel because they were conjugates, and I squared is replaced. That gives me x squared minus 100 times negative 1, which gives me x squared plus 100. Yeah? That is now if I multiply. So I've done those two. Now I got to do this one to get my final function. Okay, so x times x squared is going to be x cubed. X times 100 is 100x. Negative 4 times x squared is negative 4x squared. Negative 4 times 100 is negative 400. I check for like terms. There aren't any, but to write this, I need to put it in proper form, highest degree to lowest. So my function is f of x equals x cubed minus 4x squared plus 100x minus 400. And there you go. Alright, write a polynomial function of minimum degree in standard form with real coefficients whose zeros and their multiplicities include those listed. So they're telling me x equals 6 multiplicity 2. That means there's 2 of them. And x equals 7 plus I multiplicity 1. Anytime you get a complex 0 with an I in it, alright, the complex conjugate theorem states that guaranteed, if you have a complex 0, its conjugate is also going to be a 0. So I have another one, even though they're trying to hide it from me. So it would be 7 minus I. Okay? Now again, I want to write a function, which means I don't want to multiply my zeros together. I want to multiply my factors together. So just like we did before, I'm going to minus 6, x minus 6 equals 0, minus 6, x minus 6 equals 0, minus 7, minus I. I got to get 0 on that side. So that's going to give me x minus 7 minus I equals 0. On this one, minus 7 plus I to get rid of them both. That gives me x minus 7 plus I equals 0. Which makes my function the product of these factors. So it's going to be x minus 6 times x minus 6 times x minus 7 minus I times x minus 7 plus I. Again, I have conjugates on the end, and these two are not conjugates, and they don't have anything to do with those. So I'm going to do these two together, and then these two together, and then I'll multiply those two together at the end. That's my plan. Okay, so let me get rid of that. Alright, so for this one, I have x times x is x squared, x times negative 6 is negative 6x, negative 6 times x is negative 6x, negative 6 times negative 6 is positive 36. I like to clean it up before I go on. That's going to give me x squared minus 12x plus 36. And these two are done. Okay, now I'm going to do the last two. So I'm going to have x times x is, sorry, I'm going to put that in parentheses. X times x is x squared. X times negative 7 is negative 7x. X times positive 1 is positive Positive x times I is positive xi. I'll change colors here. Negative 7 times x is negative 7x. Negative 7 times negative 7 is positive 49. Negative 7 times 1 is negative 7. Negative I times x is negative ix or xi. Negative I times negative 7 is positive 7i. And negative I times positive I is negative I squared. That's supposed to be an I. Oh, that was supposed to be an I. Negative 7i right there. Sorry. Okay. And so now I'm going to combine like combine like terms and kill the i's. There's a positive xi. There's a negative xi. Ix, same thing. There's a negative 7i, there's a positive 7i. And this is going to turn into a real negative 1. Times this negative is going to make it a positive 1. So I have those like terms, the x's, and drop the x squared. So that simplifies down to x squared minus 14x plus 50. Okay? Now, if I distribute all of this mess out, I have x squared times x squared is x to the 4th. X squared times negative 14x is negative 14x cubed. X squared times positive 50 is positive 50x squared. Negative 12x times x squared is negative 12x cubed. Negative 12x times negative 14x. 168, what is it, positive 168x squared, negative 12x times 50, is going to be negative 600x. And then 36 goes times x squared is positive 36x squared. Positive 36 times negative 14x is negative 504x. And positive 36 times 50 is going to be positive 1800. Okay, now I'm going to clean it up, combine like terms, and I'm going to have my function is, now what are 4th degrees, so x to the 4th, negative 14x cubed, negative 12x cubed is negative 26x cubed, 50x squared and 168x squared and 36x squared is positive 254x squared. Negative 600x and negative 504x is negative 1104x. And my constant positive 1800 drops down. And there is my function. Okay? Alright, determine the graph of the polynomial function according to the given zeros and multiplicities. Well, degree 5. That's an odd number, which tells me I have to have opposite tails. Well, I can't eliminate them all, any of them, they all have opposite tails. Okay, let's see, what else does it tell me? It says that I have zeros of negative 3 of multiplicity 3. So I'd have x equals negative 3, make it a factor, plus 3, plus 3. Oh, I don't even need to know all that. Since x equals negative 3, multiplicity, an odd multiplicity, that means it's going to cross at negative 3. And it says I have a 0 at 2 with a multiplicity of 2, which is an even multiplicity, which means it will touch and turn there. So I got to have my opposite tails. At negative 3, it has to cross, okay? And here, I'm assuming is my negative 3. It's not crossing, it's just tangent there. Whereas on this graph at negative 3, it actually passes through. And you see how it kind of flattens out? That means it could be even or odd and flatten like that. It does that anytime you have multiplicity over 1. Okay? 3, again, anything odd will cross, but odd and bigger than 1 is going to cross and be kind of flattened out. Instead of just like going straight through it. Okay, and at 2, I'm assuming that would be my 2. Alright, it has to be, or no, I don't know what the heck they're counting by. Negative 5 to 5? So this one's counting by 1s. Anyway, there's my positive 2. No, that's not even crossing at 2. That's over here at 3, so that one's out. Okay, this one, at negative 3, it does cross. And at positive 2, it does touch and turn. Okay? So the graph has to be C. Alright, state how many complex and real zeros the function has. Your degree is the number of complex. That's the same as the degree. Always. Same as highest degree. Okay? Real are the ones that actually cross or touch the x-axis. So the easiest way is, I mean, look at the degree. There's got to be 2 complex. Look at the graph. It doesn't cross, so there's neither one of them are going to be real. Okay? So same with this one. Highest degree is 4, so number of complex zeros is 4. Look at the picture. It crosses twice. Here and here. So those are the only ones that are real. So 4 of them are complex, only 2 of them are real. Okay, find all the zeros and write a linear factorization of the function. Anything over 2nd degree, you need a PQ list in the graph. And let's face it, we pretty much skipped the PQ list. Again, an awesome discovery in its day. It's just the calculator is faster than the list. I'm sorry. Alright, so I can see, I'm hoping to find at least 1 because I've got to get a third degree down to a second degree. So if I can't see 1, I'm in trouble. And I can see when it crosses at 6. So I'm going to take my 6, put it in the hole, do synthetic division on my function, my third degree coefficient, second degree, first degree, constant. Okay, and I'm going to draw the line, and 1 comes out, brings back 6, 0 comes out, brings back 0, 9 comes out, brings back 54, 0 comes back, and that's my remainder, which it better be or my graph's lying to me. Now I've just dropped this down to a second degree function, x squared plus 0x plus 9. You don't need to write the 0x, so my second degree factor that's left is x squared plus 9. If I now I can use algebra because I've got it down to a second degree. So to solve this one, I'm going to just use my square root property, which says isolate the square and kill it. So minus 9 minus 9. I get x squared equals negative 9. Square root, x equals plus or minus 3i. The negative comes out as imaginary, and the square root of 9 is obviously 3. Okay, so my zeros then are x equals 6, x equals positive 3i, x equals negative 3i. Then it says write the factorization. Well, again, you don't multiply your zeros to write an equation, you multiply your factors to write an equation. So minus 6, x minus 6 equals 0, got a factor. Minus 3i minus 3i, I get x minus 3i equals 0. Add 3i, I get x plus 3i equals 0. And I can get a function, or in factored form, by multiplying those factors together. So x minus 6 times x minus 3i times x plus 3i. Okay? And there we go. Okay, so on this one it says find the rational zeros of the function and then the other zeros. Factor f of x into linear factors. Alright, now I show the completed problem, so of course it's easy for me to go, well, I think it's going to cross at negative 1/7. If you couldn't, obviously I can see the answers, but pretend that I can't see those answers, what I would do is I would go to the calculator, and I would type it in and I would calculate the zeros. This one, I didn't show it, but this one calculates out, it crosses right at positive 1. Okay, so I know one of them, x equals 1. The other one, I calculate it and I get this decimal. And if you see, when I typed that in the calculator and tried to do math enter, it just gave me back the decimal, which means it's either they didn't give me enough of the digits to make it repeat, or to make it turn into a fraction, or I don't know. So what I need to do is figure out, I need my list. I actually do. My list will actually be handy now, instead of just trying to randomly figure out what that number is. And again, pretend you can't see this yet either. So what I did was I said, well, my P has to be a factor of 25. My Q has to be a factor of 7. So my PQ list is, the factors of 25 are 1, 5, and 25. The factors of 7 are 1 and 7. So my PQ list is 1 over 1, 1 over 7, 5 over 1, 5 over 7, 25 over 1, 25 over 7. That's plus or minus 1, plus or minus 1 7, plus or minus 5, plus or minus 5 sevens, plus or minus 25, and plus or minus 25 sevens. So if it's rational, it's got to be in that list. Okay? If it's rational, meaning it doesn't have a square root in it, it's got to be in this list. Well, I've got my positive one already. Yeah? It's not negative 1. 1/7, I don't know. I know it's not 5. I know it's not 25, but I'm not good with my fractions. I don't know how big these numbers are or where they're at. I know it's in between 0 and negative 1, so it's got to be at the negative, and it's got to be small. So, I just typed my fractions in. 25 over 7 wasn't the 0. 5 divided by 7 wasn't it. 1 divided by 7, bingo, I found it. And I know it's on the negative side. So, the rational zeros are positive 1 and negative 1/7. Now, the way to find the other one is you have to divide by the rational ones to get this down to a second degree to use algebra on it. So I'm going to take my 1 and put it in the hole. My coefficients, 4th degree, 3rd degree, 2nd degree, 1st degree, constant. Sorry. 7 comes out, multiplies by 1, brings back 7. Negative 6 eats positive 7, comes out positive 1. Sorry. 1 times 1 is positive 1, comes out positive 175, times 1 is 175. Negative 150 plus 175 is positive 25. Sorry, my time. Okay, positive 25 times 1 is positive 25, and negative 25 plus 25 is 0. So again, remainder 0, which it better be, or my graph is lying to me. So now I've dropped this down from a 4th degree down to a 3rd degree. Okay, and I got to get it down to a 2nd degree, so I'm going to have to use my other 0. Negative 1/7 goes in the hole. And my coefficients are 7, positive 1, 175, 25. Okay, my 7 comes out. If you're that crazed about it, use a calculator. This is going to, negative 1/7 times 7 is negative 1. Oops. Negative 1. Positive 1 eats negative 1, comes out 0, times negative 1/7 is 0. 175 plus 0 is 175. 175 times negative 1/7 is, I'm assuming, negative 25. Let me check that just to make sure. Yes, negative 25 comes out 0. So now we've dropped it down to a 2nd degree function. So this would be 7x squared plus 0x plus 175. Ignore the 0x. My factor that's left is 7x squared plus 175 equals 0. Okay, so to solve it, I need a little more room. I'm going to come up here. Okay, and I'm going to do this down here. So I'm going to divide by 7, or I'm going to subtract 175, subtract 175. That's going to give me 7x squared equals negative 175. Then I'm going to divide by 7. Divide by 7, I get x squared equals negative 25. Then I'm going to square root, and I get x equals plus or minus 5i because of the negative. So my 4 zeros are x equals 1, x equals negative 1/7, x equals 5i, and x equals negative 5i. The rational ones are the ones that are in that list. The irrational ones, okay, are the complex ones, are the ones that have i's in them. Okay? So now, to write my function, I have to turn these back into factors. So I would minus 1, x minus 1 equals 0. And I've seen them do this. Apparently they're leaving the fractions alone. They'd add 1/7, x plus 1/7 equals 0. Minus 5i, x minus 5i. Add 5i, x plus 5i equals 0. So my function would be x minus 1 times x plus 1/7 times x minus 5i times x plus 5i. And again, in no particular order. Alright, it says write the function as a product of linear and irreducible quadratic factors, all with real coefficients. Okay, they want the linear factor and the irreducible quadratic factor. What they mean by irreducible, I'll show you. Alright, so third degree, I could try the 2 by 2 thing, it isn't going to work. So I go to my graph, and I had to play with the window a little bit, but I finally found a 0 at 19. And all I need is 1 in this case, because it's only a third degree. Knowing 1 will drop it from a third degree to a second degree, and then my algebra works again. So my coefficients are 1, negative 18, negative 16, negative 57. 1 comes out, times 19 is 19. Negative 18 eats positive 19, comes out positive 1, brings back 19, comes out positive 3, brings back positive 57, comes out 0, which better be, or my graph's lying to me. And we've dropped it now to a second degree. Now, so one of my factors, okay, I've got x equals 19, and I've got I've got x squared. Well, I don't have what x equals because I have this factor. I have x squared plus x plus 3, because this would be x minus 19, right? So I have this factor and I have this factor. Why, if I tried to factor this down more, I can't, because if I do a times c, 1 times 3 is 3. The only factors of 3 are 1 and 3, which could make 2 if I subtracted, or 4 if I added. There's no way to make 1 in the middle, so it's non-factorable. I could solve it. I could do quadratic formula and get the solution, but I cannot factor it. So the linear factor, because it's to the first degree, is x minus 19. This one's the quadratic factor because it's second degree. Alright. Chapter 9. If a club consists of 18 members, how many different arrangements of president, vice president, and secretary are possible? Remember my lunch scenario. Alright? You're not just picking 3 out of 18 to go to lunch. You're picking them specifically to fill a president, a vice president, and a secretary role. So the order absolutely matters. When that is the case, you use the NPR instead of the NCR. Okay? So if I NPR, but we have 18 objects and we are picking 3 of them in a certain order. If you type that in the calculator, you get 4896. Okay? Alright, so again, type that in the calculator, you'll get 1680. Type it in the calculator. Remember, this one will be choice 3 instead of 2, I think. NPR is 2 and NCR is 3. Alright, use the binomial theorem to expand the expression. Alright, first we need our coefficients. To get our coefficients, we do 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And I'm gonna drop my calculator. Okay, so I'm gonna go to my calculator and I do type in math, then type in 4, then math, arrow over to prob. And I want choice 3. Then I'm going to open my bracket. And I do 0, 1, 2, 3, 4. Close my bracket. And hit enter. And it gives me my coefficients, which is going to be 1, 4, 6, 4, 1. Okay, and then we start our expansion. So we're going to have 1 times m to the 4th, n to the 0, plus 4 m to the 3rd, n to the 1st, plus 6 m to the 2nd, n to the 2nd, plus 4 m to the 1st, n to the 3rd, and last but not very least, plus 1 m to the 0, n to the fourth. So if we clean this up now, we're going to have 1 times m to the fourth times 1, because anything to the 0 degree is 1. That's going to give me m to the fourth, plus 4 times m cubed times n, plus 6m squared n squared, plus 4mn cubed, plus, that's going to be 1 times n to the fourth, which is just n to the fourth. And there's my expansion. Okay? Alright, and this, they just want you to realize that they're telling you to do 9, choose 5, type it in the calculator, you get 126. What is the coefficient of w squared, y to the 6th, and the expansion of w plus y to the 8th? Okay, that formula, if you don't remember, is going to be n over r times a to the n minus r, b to the r. Now, to figure out what r is, when they give you the exponent, in other words, they're not saying find this term. When they say find this specific term, your r is always going to be 1 less than what they tell you to. Or is it 1 more? Yeah. Okay, if they give you the exponent, all you do is take this exponent and subtract the first one. So 8 minus 2 is 6. So my r is 6. My n is 8. My a is w. And my b is y. So in my function, I'm going to have 8 over 6. My a is my w to the n minus r. 8 minus 6 is 2. And b, my b is y to the r. My r is 6. So if I get the 8 choose 6 in the calculator, 8 math, arrow over to prob, 3, 6, I get 28 w squared y to the 6th. Now they didn't ask you for the whole term, they just asked you the coefficient of that term, which is why they only answered 28. Okay? Alright, and then it says use the binomial theorem to find the polynomial expansion for this function. Okay, so because my n is 3, first of all we have to find our coefficients, which is going to be 3 choose 0, 3 choose 1, 3 choose 2. And if I type that in the calculator, I got 3, math, arrow over to prob, 3, bracket, 0, comma, 1, 1, comma, 2, I forgot one, silly goose, comma, 3, close your bracket, I get 1, 3, 3, 1. So when I start my expansion then, I'm going to have my first coefficient times a, which is 2x to the third, times 7 to the 0, plus my next coefficient 3 times 2x to the second, times 7 to the first, plus my next coefficient is 3 times 2x to the first, 7 to the second, plus my last coefficient, 1 times 2x to the 0 times 7 to the third. Okay, so if I clean this mess up, I'm going to have 1 times 8 times x cubed times 1. Anything to the 0 degree is 1. Plus 3 times 4 times x squared times 7. Sorry, I guess I should explain. 2 cubed is 8. 2 squared is 4. Okay, 7 to the first is 7. Plus, sorry, I'm going to switch colors. Plus 3 times 2 times x to the first times 49, because 7 squared is 49. Plus 1 times 1, anything to the 0 degree is 1, times 7 cubed is 343. And finally, one more sweep and we should have it, would be 8x cubed plus 3 times 4 times 7 is 84x squared plus 3 times 2 times 49 is 294x plus 343. And there is my expansion. Alright, and that is it. So happy studying. Do good on your test, and I will see you next time.